Hello guys, and welcome back to another week of remote learning. So this week we're going to kind of focus on basically scientific thinking. How do you work your way through a problem from start to finish? And I wanted to kind of start with this introduction on both what the project is and why this skill is so important for daily life. And I wanted to start with a story about something called Vulcan. So when I say Vulcan, what comes to your mind is this guy right here, Mr. Spock. We're actually talking about a different Vulcan here, so not this guy, which some of you guys may not know who that is, and that's okay. Or is it? But anyways, so Vulcan was this idea. It was actually a hypothetical planet, meaning back in the mid-1800s, people thought that there was this hypothetical, I mean, they weren't sure, but they kind of thought that there was a planet in between Mercury and the sun. And the reason why they thought that is because they had a problem, right? As they were studying all these different planets and they were starting to basically piece together what our solar system looked like, they noticed that Mercury was kind of weird. The way it orbited around the sun was actually unusual and didn't really fit with the way that they understood gravity at the time. So their proposed explanation for that was Vulcan. There was another planet there, and that planet was what was tugging on Mercury a little bit in terms of force and gravity and all these things, and caused that orbit to change. And people basically kind of went with that theory for many, many years. They started saying, oh, I see things in the sun, different dips in light and things like that. And they had this theory about Vulcan up until Albert Einstein. Albert Einstein actually disproved the idea, and it came through scientific thinking and scientific testing. And basically, he used a lot of math to figure out that actually it's not another planet there. And then we were able to later confirm through many, many more tests and things like that. But I tell you this story because I want you to kind of think about, how did they try to confirm that hypothesis, right? What kind of testing did they do? And why is it important to do any kind of testing? How do we go through solving a problem? And a lot of times, like the story of Vulcan, it takes time. It takes a lot of resources, and it takes a lot of people to come up with the right solution and solve that problem. So here's what you're going to do. In this project, you're going to basically find your own problem. And I'm going to give you a list of topics to go through. Now, you can use some of the things that are on this list as kind of a jumping off point of some problems that are in your environment, things that interest you. But it's not the only thing they're not the only ideas that you can use. If you have other ideas that you think are really interesting, send me an email and I'm happy to help you out with those. Before you start your project, you'll want to make sure that you get your topic. So let's go through kind of step by step what you should be doing for this project. Okay guys, so there are 3 parts to this mini unit or mini project, whatever you want to call it. And they're kind of all broken up in what I'm going to post on Google Classroom for you with some rubrics and things like that. But the first step is to find a problem. So this can be pretty much anything that interests you within the realm of science. And I gave you some starting ideas there, including invasive species. If you're really interested in animals and ecosystems and things like that, that might be an interesting one for you. You could also go with technology. If you're really into the cellular, molecular stuff and thinking about how we use that, and also other types of scientific technology, including robotics and things like that, or AI, you can talk about any problems that those are solving or any problems that they might potentially cause in the future. So those are some starting ideas for you, but you want to pick something that is interesting to you. So find something that is in your wheelhouse. Again, if you're interested in animals, go with an animal thing. If you like technology, find a tech thing. It is really up to you, and I hope that you find something that is interesting so that you can kind of just delve a little bit deeper into that. Now, step number 2 is peer review. So peer review, you'll want to post a little bit on Google Classroom about your project, about whatever topic that you are picking for this, and you're going to go through and comment and ask questions on at least 2 other people's project. So when you do that, you need to make sure that you are putting thoughtful responses here. Again, the point of peer review is to improve your own idea. The idea is you might have one perspective on something, but then when somebody else enters the conversation, that perspective can change a little bit. Quick story here about perspective, and I'm sorry if I've told this story to some of you guys before, but when I was younger, I had this camera. It looked like this. It was pretty great. It was a Barbie camera. And my dad took me to go canoeing in Wekiva Springs, and the entire time we were just pointing out all the different birds, the different wildlife that we saw, and he's like, oh, get a picture of that, get a picture of that. Well, I was doing all this, I was so excited, and I was just taking pictures left and right? And then we go to the CVS, or it wasn't CVS at the time, it was something called Eckerd's, which doesn't exist anymore, and we had to develop those pictures. Now we got the pictures back, and they were all pictures of my eye. Every single picture ended up being a close-up of my eyeball. And I realized I was holding the camera the wrong way the entire time. Again, this is probably why I'm not a photographer by any stretch of the imagination, because my first kind of foray into that ended up so horribly wrong. But it's a good lesson on perspective. Oftentimes, you might think that your perspective is including every angle that you want it to. But in reality, involving more people in that conversation, for example, when my dad finally told me to turn the camera around, I got better pictures. And so that's why we're doing peer review, is to basically get some extra insight into it, to get some extra voices into the conversation that can help make your overall project a lot stronger. Make sure when you're doing that, I want to make sure you're avoiding something like this. Even though some of you guys might be tempted to just say just all positively, oh, this is the best thing ever, I agree, that is great. I want you to be encouraging to each other. But I also want you to help the other person think of new ways to think about their problem. So instead of just saying, I agree, you need to say something like, oh, that's a good point. What about this? What about that? So make sure that you're adding a little bit to their responses when you do respond. And then finally, the third part of this is going to be, and again, I forgot to mention here, but for point number 1, it'll be a quick little PowerPoint or Google Slides. There'll be a place for you to put that on Google Classroom. For point 3, how do we solve this problem? What you're going to do here is you are going to basically write step by step, hypothetically, meaning if you had all of the resources, all of the time in the world to solve this problem, how would you do it? And here I'm looking for kind of seeing, how are you thinking through the problem? Are you taking into account what those peer reviews said? Are you thinking about the logistics of it? Like, what could go wrong? And you'll also need to make sure you put a couple of things in there about some points that could go wrong and what you can do to try to make sure that doesn't happen. Again, if we're doing this in the real world, there are lots of places where things can change. Think about the Vulcan problem where we talked about earlier, that whole planet. It changed, right? Our idea of how planets and how they orbit ended up changing over time. And as more scientists enter the conversation, lots of things change again. I really like this quote, and it said, part of understanding science, and I'm paraphrasing here so it's not exact, is understanding that there are many ways to be wrong, or many ways that things could go wrong. So I want you to think about that as you're coming up with your game plan. Obviously, for some of these problems, they're really, really big problems, especially if you're picking something that is more about like how big climate patterns are changing. It takes more than just one person writing a plan to obviously change this, but it's something to get us started. And again, just think about if you had all the resources and all these other people into the conversation, what would that look like in a perfect, ideal world? So that is your assignment for this week. And I hope that you guys are able to find something that interests you, that you're able to think about it critically, because again, the reason why we're doing this is basically so that you start to get that skill set, which will help you not just in science, but in other classes as well. Thinking through problems is something that you can't just Google. It's a skill, right? So that's the point of doing this, and I'm here to help. During our Zoom sessions, we'll hopefully you can, give me some ideas, and I'll give you feedback on it, and I can't wait to see what you come up with. All right, guys, have a good one.